I can use models to show and explain whole numbers as fractions. In this case, when I talk about models, what I mean is rectangles, squares, circles, or polygons, different shapes that we can partition into equal parts and then show fractions. In this case, we're talking specifically about whole numbers, like 1, 2, 3, 4, and so on. This first model, is a circle with two equal parts. Both of them are shaded in, so you have 2 halves, which equals 1. The second model has a circle again and has 1, 2, 3, 4 equal parts. All 4 are shaded in, so you have 4 fourths, which equals 1. What I'm trying to show you here is basically this. Any fraction number over that same number equals 1. So whether it be 2 over 2, or 4 over 4, or 100 over 100, it equals 1 whole. Here's an example of going beyond 1 whole. You have 1, 2, 3 whole bars here, and in each bar there are 1, 2, 3, 4 equal parts, in which case all 4 are shaded, so you have 4 fourths, 4 fourths, and 4 fourths. Well, either using multiplication or skip counting or repeated addition, you can realize that 4 plus 4 plus 4 is 12. So really what you have there is 12 fourths. But this is something we don't really use much. So 12 fourths is actually just 1, 2, 3. It's another way to write 3. And just as a thought, when you're dealing with wholes, well, if the whole thing was shaded in, that would mean one piece, so it would be a denominator of 1 because it's one equal piece, and you're dealing with 3 of them, so it's actually 3 with a denominator of 1. Any whole number can be represented like that. Here's another example with circles. You have 1, 2, 3 equal parts in both circles, and the entirety of both circles are filled in. So 1, 2, 3, 4, 5, 6. 6 equal parts. They're divided into thirds. Basically, what it's saying is that equals 2, though. You have 2 whole circles filled in. 6 thirds equals 2, which equals 2 over 1. Any one of these is an appropriate way to say this fraction. All whole numbers, 1, 2, 3, 4, 5, 6, all the way up to, you can keep counting forever, can be written as a fraction n, any number, over 1. It just has to be a whole number. So in this case you have 1, 2, you put the 2 over 1, and you can write it as a fraction. All whole numbers can be written as this, n over 1. Here, for example, are some number lines I wanted to show you, just to see what whole numbers look like on a number line. You have 0 and 1, and it's broken into eighths. 1/8, 2/8, 3/8, 4/8, 5/8, 6/8, 7/8, and then 8/8, which falls at the exact same mark as 1 because they're equivalent. They equal each other. Same down here, you have 6. You have 1, 2, 3, 4, 5, 6 equal parts between 0 and 1. 1, 6, 2, 6, 3, 6, 4, 6, 5, 6, and then 6/6 would be next, but we usually just label that as 1 because they're the same thing. 6/6 equals 1 whole. Back to our learning target. I can use models to show whole numbers as fractions. What I want you to do is to look at these bars, there's 1, 2, 3, 4 of them, and to write the fraction shaded in 2 different ways.